Hi, I'm Victor, the main organizer of the Full Stack Flutter conference. On this channel we publish the best talks from the conference every week throughout the year, so make sure to subscribe so you don't miss out. I'm also the founder of Serverpod, so if you want to build your backend in Dart, make sure to check that out too. Köhler is the CTO and co-founder of Journey, an app that makes it easy to plan your travels. He'll talk about streaming data with Serverpod. Let's go!
Hello and welcome to making live updates a joyride with Serverpod. My name is Köhler and I have been a full-stack developer for quite some time now. I have started with .NET and Windows Forms, later on moved to Angular and Java, and since 2018 I have been using Flutter for development. I'm also co-founder and CTO of Journey, and I'm deeply in love with ramen. If you haven't tried that yet, you really should do so. But I also got problems. My problems are that I have very little time. I also got critical business logic that requires to be run on the server, and I want to use the same language for app and server. I also need a SQL database and want to have real-time updates. So, what is Serverpod? Serverpod is a server framework written in Dart. It comes with an ORM for PostgreSQL databases and has code generation for models and clients. It is also free and open source and has easy deployment for AWS, Google Cloud, and I'm currently working on a pull request to introduce Docker Compose so that you can deploy to your virtual private server or to your dedicated server. Let's see what we will be working on. A little text chat to demonstrate the streaming capabilities of Serverpod. We will start, of course, with the Serverpod side. How does it work? We will define database entities and DTOs in YAML files. We will generate the ORM and client code and database migrations and pass serialized objects through authenticated WebSockets. Sounds a lot? Don't worry, it's gonna get really easy. Building the server involves a few steps. We will define the entity in YAML, generate the database and Dart code, create our endpoint, add the streaming methods to that, and generate the Flutter client. Let's start with the YAML file. In Serverpod, any DTO and table is declared in a YAML file. And if you want a class to also have a database table, you define the field table, which is optional, but if you do so, there will be a table generated for that. Right now, we create our text message, and we need an author, a text, and a timestamp. Since we will be sorting our text messages later on by the timestamp, I also created an index in the database to improve the query speed. We then run Serverpod generate and Serverpod create migration, which will first create the Dart code for our defined YAML and create a migration that will create the necessary database structures for our new table. Let's create the endpoint. In Serverpod, endpoints all extend the endpoint class. Our endpoint wants to do some streaming, so we will override two methods, one being stream opened and the other handle stream message. Let's get deeper on stream opened. Stream opened is called whenever a client opens a streaming connection. In Serverpod, sessions are bound to a specific client, and if you want to get any message that is sent to the server to another client, you do that by subscribing to that topic, or otherwise called the channel name. In this case, we do it very simple. Whenever a stream is opened for that client, we also add a listener to the channel text message and just forward the message to the client. Next, onto handle stream message. This method is called whenever a client sends a message to the stream of this endpoint. In this case, we will check if our message is a text message, and if so, insert it into the database and then post it to the messages of this endpoint. This has the previously added listener called, and it will then send the stream message to any clients that are subscribed to this channel. We will also need a method to read the previous text messages. To define a callable endpoint method in Serverpod, you only got to declare a public method with the parameter session in it. In this case, we will just read the first 1,000 entries in text message database ordered by the timestamp. We will then run serverpod generate once more so that the client package is updated with the new endpoint methods. After doing that, let's get into the Flutter part. Connecting the app involves a few steps too. We need to initialize the client, fetch the previous messages, set up our streaming connection, listen to new messages, and make sure that in the end everything is disposed properly. So let's create a simple stateful widget. Let's call it text chat. And in there we will add our client. Please note that in a real world scenario, you would have your client somewhere globally because this class should be instantiated only once. You would use some sort of state management to do that. Also note that localhost is a getter from the Serverpod package, helping with the Android localhost issue where it is a IP instead of the usual alias which you can use on other platforms. But let's get deeper into connecting our stream. We will need a few fields to handle our stream, and besides the client which we already added, we will add a streaming connection handler, the streaming connection status, a stream subscription field, and a list for the text messages. Note that the stream connection handler also is something you should have instantiated only once in your whole app, and usually you would want to have it at the same place where you keep your client. Streaming connection handler is a very handy class helping you to stay connected to the server. Whenever the internet connection is interrupted, the streaming connection handler will retry to connect, and you don't have to handle the logic of reconnecting to the stream manually. Let's get into the methods. After adding our fields, we will override the initState method and add two methods: read previous messages and initialize stream. Let's first fetch the previous messages. And this is done from the generated client, and we just have to call client.textMessage, which is the endpoint we created earlier on the server, .readAll, which is the method we defined in the endpoint. This will respond with a list of text messages. We will add that to the text messages in our state and sort them by the timestamp. Then in the initialize stream method, we will do two things. First and foremost, we gotta listen to the stream itself. This is just a default Dart stream, and we can call listen on that, or even would be able to use an async for each. In this case, I prefer to use listen because it's a little more declarative. Also, I get to dispose the streaming subscription myself. So whenever an event is emitted from the stream, I check if it is a text message. And if so, I add the text message to the text messages in the state, and again sort them by the timestamp. In initialize stream, I also initialize the connection handler Again, keep in mind, this is something you would do in a real scenario only once at a specific place. For simplicity's sake, I put everything in one place. And before building UI itself, we need to make sure that when the app is closed or the widget itself is disposed, we properly dispose of the resources. So I'm overwriting the dispose function and calling my new method closeStream. In closeStream, I'm canceling the stream subscription and closing the streaming connection, and after that, disposing the connection handler. This is important to keep in mind. The streaming connection handler, when disposed, will not close the WebSocket to the server. It will only dispose itself. So if you want to close the streaming connection to the server itself, you will have to explicitly call close_to. Now, a little example how you could use ListView.builder to display the text messages. Let's see how the full example will work. Here, Serverpod and Flutter are having a little chat, and I've started the app 2 times to show you how the streaming will work out in the end. After having seen this very basic example, I wanted to take you a little bit deeper into how I at Yorni implemented streams with Serverpod. Yorni is an app which helps you and your friends to decide upon the best accommodation for your vacation. You will swipe the hotels just like you would do in dating apps. And you can do this whenever you get time. One would swipe in the morning, the other in the evening. And you could always see in real time the state of your other vacation participants, which is where streaming comes in. And in the end, get notified when everybody is ready to book a hotel where everybody agrees upon. So let's take a look at some code. And this is the vacation endpoint. The vacation is the entity I use to display and hold the information on a single vacation. Here, the clients subscribe to updates on specific vacations by sending a vacation select message. In my case, I do the listening on the channel not as soon as the stream is opened, but only when the client requests a specific channel to be listened to. So in this case, sending a vacation select message will result in fetching the participant and calling setUserObject. This is very helpful. SetUserObject is a function from Serverpod which allows you to associate a specific object with that session so that you can use it later on, for example, when handling a stream message or before sending a stream message. Whenever a message is sent to the channel for this very specific vacation, the client requested to be listened to, it will be forwarded. In this case, I'm calling a method called forwardMessage. What this will do, we will see very soon. Take note that in session messages.addListener at the very bottom, I am dynamically creating the channel name by inserting the vacation ID. When a stream message is received, either from a client or from the server which has posted the message, it is checked whether it is the correct type. If it is a vacation select message, we don't do that here, we just return. I then get the session info, the user object, by calling getUserObject and make sure the user is authenticated and also part of the vacation. And if the message I received to the stream is a vacation, I will just send it to the client. This comes in handy, for example, when a vacation is updated. In this case, the update endpoint call is called from a client which changed the name of the vacation. The vacation is fetched from the database, some sanity checks are done, the vacation is updated, and then the new vacation object is sent to the channel of the vacation ID. So the code we saw earlier would then be run, and every client that is currently looking at that specific vacation would instantly receive the updated vacation info. If you want to get started with Serverpod Dev, I highly recommend you to check out the documentation at serverpod.dev. And if you want to see the full example code, feel free to get to my GitHub and check it out. If you got any questions, I'm hopefully providing the correct answers and am happy to listen to you. If you got any questions, I'm happy to answer them, and I hope that my talk helped you in some way, and looking forward to seeing you using Serverpod.